Hi, this is Mr. Bledsoe, and in this video I'm going to show you how to use something called a factor tree to find the prime factorization of a number. So let's say I wanted to find the prime factorization of the number 24. So I would write down the number 24 and then I would make this kind of little two lines coming off of it at the bottom. And then I would ask myself, what is a number that I know will divide evenly into 24? That is, what is a factor of 24? And it doesn't matter which one I start with, but since I know 24 is an even number, and I know all even numbers are divisible by 2, then I'm going to say, well, 2 I know is a factor of 24. So I'm going to write down 2 as one of my factors at the end of this first line coming off of 24. And then at the end of the other line, I'm going to write 12 because that's the partner factor of the factor pair 2 times 12. So 2 times 12 equals 24. So that's kind of the first level of my factor tree. And one of the things that I notice is that this factor here on the left, factor number 2, that's a prime number. In other words, I can't break down 2 anymore since it's a prime number. So I'm finished with that particular branch of the factor tree. Well, 12 I know is not prime. 12 is a composite number, which means that it has some additional factors. I can break 12 down into more factors. So what is another number? What's a number that's a factor of 12? Well, again, since 12 is even, I know that 2 is a factor of 12, and the partner factor that goes with 2 would be 6, because 2 times 6 equals 12. So I write those two numbers down under the two little branches that are coming off at 12. And once again, 2, I notice, is a prime number. That is a prime factor. So again, I'm done on that side, that particular branch of the factor tree. I still have 6 though. 6 is not prime, which means I can break it down again. So 6 again is even, so 2 is a factor, and 2 times 3 would be my other factor because 2 times 3 is 6. And since 2 and 3 are both prime, well then I can't break down that factor anymore. I can't break down the factor 3 anymore, and I don't have any other composite numbers in my factor tree to break down, which means I'm finished factoring the number 24. That is, I have found the prime factorization of the number 24, and the prime factorization of the number 24 is 2 times 2 times 2 times 3, which, as you notice, is just the numbers at the bottom or at the ends of each of the branches of my factor tree. And that's how you use factor trees to find the prime factorization of a number. Let's try another one. Let's say we wanted to find the prime factorization of the number 75. Well, again, I'm going to start by drawing my two little branches here off of 75, and I need a number that is a factor of 75. It doesn't matter what number I choose, it just has to be a factor of 75. 75 is not even, so I can't use 2, so I need a different number. Well, I notice that 75 ends in the number 5, which means I know it's going to be divisible by 5. So 5 times something equals 75. And you may not know, what the other factor is. You know that 5 is a factor, but you don't know what the other factor is. If you don't know, and if you can't do that in your head, then again, you can always kind of do a quick long division here, and you will find out pretty quickly that times 5 is 5. 5 goes into 25. Oops. 5 goes into 25 5 times. And I can see that 5 times 15 is equal to 75. Well, the number 5 is prime, so I'm finished with that side of the factor tree, with that particular branch of the factor tree. 15, however, is not prime. 15 breaks down into 3 and 5, and since 3 and 5 are both prime, then that means I've come to the bottom of each of the branches of my factor tree, which means I'm finished. And now I know that the prime factorization of 75 is, I'd write it like this, 3 times 5 times 5. You typically write each of the prime factors in a prime factorization of a number. You typically write them in order from lowest to highest. So 3 times 5 times 5 is the prime factorization of the number 75. All right, so let's try one more. I want you to do this one. I want you to try to find the prime factorization of the number 72. So pause the video right here. You try to find the prime factorization of 72, and then you come back after you've tried and see if we get the same answer for our prime factorization of 72. Okay, so I want to find the prime factorization of the number 72. I'm going to use my factor tree diagram here. So I draw my two branches off of 72, and I notice that 72 is an even number, so I'm going to start with the number 2. 2 times something equals 72. I happen to know that 2 times 36 is 72, and 36 gives me, 2 times 36 gives me 72. And again, 2 is prime, so I'm finished with that particular branch of the factor tree. 36. I need two numbers. I need two factors of 36. I could use 2 again because I know that 36 is an even number, but just to show you that you don't necessarily have to always use 2, you could use any number that's a factor of 36. I'm going to use 6 and 6. I know 6 times 6 equals 36. But now notice 6 and 6, neither one of those numbers is prime, so I can't stop. I've got to keep going both with that 6 and also with that 6. So do the one on the left. 6 is equal to 2 times 3. 2 and 3 are both prime. So I'm done with those two branches of my factor tree. And then this 6 is also 2 times 3. And again, those are prime. And I'm finished. I've gotten down to the bottom of each of the branches of my factor tree. I have a prime number on each one. So now I can write that the prime factorization of 72 equals, let's see, I've got 2 times 2 times 2 times 3 times 3. And there's my prime factorization of 72.